This is the second part of a tutorial series about linked list, which in turn is inside the whole playlist. So go ahead and check out the link in the description for the whole playlist. And if you want some coaching from me, go ahead and check out the first link in the description. Now, let me just jump into the playground that we had previously. Now, we started creating a linked list, meaning that we created the node, and then we talked about the head, the tail, some properties, and then we implemented the push and the append and what that actually means. Now, I slept on it, and I just want to make a few little changes. One is a bug actually right over here in the push. A good thing that I noticed that. And the second one is just an improvement on life on the append. So let's take a look at the push bug fix. Now, right over here, when we are pushing, remember we are adding right over here like 0, and then at the beginning, so-called beginning of our linked list at the head, we are actually removing the current head and replacing it with this new one, right? So yeah, we did that. As you can see, we said the head is making sure that we have the new value, and its next node is the current head. So then we are returning the new head, which is fine. But we did not take in consideration what happens with the tail. So let's fix that right over here. After we set the head, we say, is the tail nil? So is this the very first element that we are introducing into the linked list? So if tail is equals nil, then what is our tail? Well, it is equals to our head. Remember, as I told you, is the very first element that we are introducing. So that's the bug fix on the push operation. Now, right over here on the append, which again, this is just like this. So we are appending at the end. We basically just did the operation, and that's it. Now, what we saw over here that we are returning the created linked list node. So I figured, why not? Let's just do that also on the append. So making it sure that we are having it as a discardable result, meaning that we might or might not care about the return statement. Push, as you can see, it's already returning a linked list node, so we just need to remove the return from here and put it in front of the push. And then we need to also return our tail right over here. And basically that's it. Again, the defer will be done right before we return this tail. Okay, so those are the quick fixes from the previous episode. Now, next up, we want to add, well, this is from the previous one. We want to add an element, a new node, right inside after the linked list after a particular node. So let's say right over here, as you saw it right over there. Let's say if we wanted to add 5. 5 will be added after a particular node. And before, we just need to also make sure that we rewire the connections. So what we need to do is to just traverse our linked list all the way up to that particular node that we want to add our new node after, and then unlink the next. We are going to unlink 3 over here from 2, link it up with 5, and then link up 3 with the node of 5. 3 meaning that it will be next on the 5 node. I know it seems a little bit complicated, but basically that's it. We are going to write out the code now. Now, there are 2 steps to this. First of all, traversing, so going all the way up to the previous node, and then doing the actual linking and unlinking of the nodes. So first, we are going to traverse to the actual previous node, and then we are going to insert 2 functions. Let's just go all the way down after the append. Let's take care of the traversing to that node. Now, this is the only time complexity heavy operation in a linked list. When we are traversing, because that's O of I, meaning I the index that we want to traverse. Therefore, because it's a two-step process, even though the insertion is constant time, the whole operation will be O of I time. Pushing, appending, popping, and removing last are also O of one constant time, one time, yeah, you know, it's constant, and then removing at a certain index will be again O of n. But we are going to get there at the end of this video. Enough talk, let's write our code. This is going to be a public function, so public func node at index, and that will be of type int, and it will return the linked list node that we want to add, basically, which could be optional. You know, we might not be able, oh, sorry, not what we want to add. We are traversing and we are searching the previous node. Again, two steps. It might be optional. We might be inside an empty linked list. So we want to return nil there. We might be at the end of our linked list. So this could be an optional. So first of all, we need to make sure that the index is in scope. What that means, it has to be greater than or equal 0, and it has to be less than the count of our linked list. Remember the previous episode, we set up our count, and when we appended, we bumped up the count by 1. So first of all, go the guard statement. Guard index is less than equals 0. Oh, sorry, greater than and equals 0. And the index would be less than the count. Else, we are going to return nil. So return nil. Great. Okay, so how do we actually traverse? Well, there are two options where we are going to use a while loop, and we need to consider when we are going to break. Either we are getting at the nil value as the current node, and you know that could be when we are at the end or there are none, but you know we already going to guard against that. Or whether we are getting to the particular index that we are looking for, therefore we are going to return that current node. So two variables right over here. Current node, which is going to start with the head, and then var current index, which is going to start at 0. And then let's, oh, by the way, it's missing. I'm just going to add the return statement of our current node, right? So we are going to start with the head, and we are going to replace the current node each and every time the current index is going to be bumped up with the next one. So remember, the linked list has a next node, and we're going to replace it with that until we get to our desired index. So while current node, first of all, we want to make sure it's not nil. In that case, we either got an empty list, or we got to the tail of our list, and we make sure that the current index is less than the index. Great. So if none of these are, so while both of these are true, we are going to say just go to the next node. So current node equals the next node, and we're going to bump up our current index plus equals 1. And because current node is not nil, at this stage we're just going to bang that out with a bang operator. Okay, and that's how we traverse to a particular node. We need to know the node because linked lists are not index based. So we need to know where we are going to insert our new node right over here. Okay, so next is to insert the value after that particular node. Okay, let's just scroll down and create our new function over here. It will be returning the node that we inserted, so we might not care about it. We are going to make this a discardable result, public it's going to mutate our linked list. So mutating func insert our new value of type value, and then after our node, and that will be a linked list node of type value. And of course, we are just going to return our inserted linked list node that will be of type value. There we go. And this is not an optional because, we are always going to create a linked list node out of this value. Okay, so how do we do that? Well, we already have the node. Remember, with node at the index, we are going to grab that particular node. And then we just say node dot next. So we are going to unlink the current node and add in this new one. So that is linked list with a value. We have a value, and now we unlink it, but we still want to link it back to this newly added list. So the next would be actually going to be the node dot next. Now, this one is actually 2, the value 2, this is 5, and then the node.next value is 3. If we take a look at the example that I was providing at the top of my file. Now, why does this actually work? And it might be a little bit counterintuitive. Node.next, it's the same node over here. Well, we are first evaluating, when we are assigning a value, we're first evaluating the right-hand side of the equation, right over here. This time around, the node.next is still free. And then we are assigning node.next to this new linked list, which is going to be with a 5 with the next value of 3. Hope that makes sense. Okay, then we are going to return our node.next, and we can just bang it out with a bang operator because we do know that it's going to be available. Let's do the defer. I'm not going to talk much about the defer right over here. Go ahead and check out the previous episode so you better understand what it does. And finally, what we need to address is one tricky situation. What if our node that we want to insert our value after is actually the last one, the tail? Well, that's actually how we are going to append. So we want to guard against that. Guard, it's not the tail, else we're going to do something else. Otherwise, just go forward. And we are going to append. So the append functionality also has a returning a linked list node. So we are just going to return append and then value. Simple as that. Okay, so you do want to make sure that, it's not tail, sorry, node. We are checking against tail and node. So the tail should not be the node that we are inserting after. If it is, it's just a simple append. Great. Now it's time to make this even simpler because, this would be a two-step operation. First, we need to find a node and then we want to insert it. It would be really nice if we just had an insert value at index, not after node, and then we just want to node at index. Let's kind of make these two functionalities into one. It's still going to be a discardable result and a public mutating func insert value of type value, and now at index of type int, and it's still going to return us a linked list node. But because our node at is returning, which we are going to use, returning an optional linked list node, we are going to need to return right over here also an optional linked list node with a value. Okay, so what do we need to do? Well, first of all, we need to grab our previous node and then we want to insert it. That, again, would be an optional, so we want to guard let against it. So previous node at index -1, because, you know, we are inserting at that particular index. We want this value to be at that index. So the previous would be index -1. Else, we are just going to return nil. You know, in many cases, you know, it's the index. It could be anything. It could be in -10 or whatever. Want to make sure that you're returning nil right over here. And then we are just going to return insert. So we are just going to insert value, not at, but after value. And after our previous. Great. This seems really nice, but there are some edge cases. Now, first of all, we want to make sure that the indexes are great. So guard index is greater than or equals 0, and index is less than or equals our count. Else, again, we are going to return nil. Okay, so you want to make sure that it's in that particular range. Now, what happens if the index is 0? Well, basically then we want to push at that value. So we want to guard against that too. Index should not be 0 for the other stuff to go through, so a 0. Else it's just going to return a push, so return push with a value. And the same goes for when the index is equals to the whole count. So we are just going to append, basically, because we want to insert a value after the tail, so after the last value. Node, sorry. Guard index is equals, so it's not equals, it's a guard statement, not equals our count, else. And here we are going to return append our value. Great. So that's how we insert. Now let's check it out. I already have pushed right over here 2 things. Let me just duplicate this again. Push 3, and then let's run this. There we go. So 1, we're pushing 2, we're pushing 3. Because we are pushing at the head, let's just take a look at the append. It would be a little bit more easier to understand. And by the way, we are also going to check out that the append is also working. So 1, then 2, then 3. Great. So what we want to do is go linked list dot insert, and let's just go with 5 maybe at index. Now this is 0. 0 we have 1. I want to insert it right in center right over here. So insert at index 1, and then I'm just going to print out our linked list. Let's build that once more. There we go. We inserted 5 at index 1. So basically after index 0, but here it is at index 1. We just pushed 2 and 3 all the way up. And yeah, basically that's how you insert new node inside a linked list. Now in the next video, we are going to talk about popping, removing the last, and then removing at a certain index, or rather removing after a certain node.